Okay, so you want to build a data center. Find some land, pour some concrete, fill it with servers, rent out the computing power. Simple enough. The global data center market is projected to be worth well over $500 billion by the end of the decade, and some estimates for the broader ecosystem, including the AI infrastructure boom, push that figure past $1 trillion. Surely this is just real estate with extra steps. It isn't, not even close. A data center is one of the strangest hybrid businesses on earth, part real estate, part utility company, part technology infrastructure, and understanding that combination is the only way to understand why this industry suddenly became one of the most capital-hungry sectors in the entire global economy. Let's start with the number that resets how you see the entire industry. A single hyperscale data center, the massive facilities built by companies like Amazon, Microsoft, and Google, can cost $1 to $2 billion to construct, and the largest AI-focused facilities being announced now are pushing past $10 billion for a single campus. To put that in perspective, that is more than the cost of building an NFL stadium, and these companies are building dozens of them simultaneously across the globe. Here's the part almost nobody thinks about before they picture rows of servers. The actual servers and computing hardware inside the building often cost more than the building itself. A single high-end AI training server rack packed with the most advanced chips can cost $200,000 to $400,000. And a large facility might house tens of thousands of these racks. For context, industry estimates suggest the compute hardware inside a major AI-focused data center can represent 60 to 70% of the total project cost, meaning the concrete shell you'd picture as the data center is often the smallest expense in the entire build. So before a single customer rents a single server, you're already carrying staggering fixed costs. First, there's power. A hyperscale data center campus can require anywhere from 100 to 300 megawatts of continuous electricity, enough to power a small city, and that power has to be available 24 hours a day, 365 days a year, because even a few minutes of downtime can cost cloud providers millions of dollars in service credits owed to customers. Securing that much guaranteed power often requires data center operators to sign decade-long contracts directly with utility companies, and in some markets, operators are now funding entirely new power plants themselves just to guarantee the electricity supply their facilities need. Then there's cooling, and this is where the physics of the business get genuinely brutal. Densely packed server racks generate enormous heat, and modern AI-focused facilities are increasingly moving toward liquid cooling systems because traditional air cooling simply cannot keep up with the heat output of the latest chips. A single large data center can use anywhere from 1 to 5 million gallons of water per day for cooling in facilities that rely on evaporative systems, which has made water rights and availability a genuine constraint in drought-prone regions where many of these facilities are being built. Then there's the network infrastructure connecting these buildings to the rest of the world, dedicated fiber optic connections, redundant backup systems, and on-site power generation for outages. Backup diesel generators and battery systems that alone can add tens of millions of dollars to a single facility's construction cost, purely as insurance against the kind of outage that could cost far more in lost business and reputational damage. Now here's the part that explains why investors keep pouring staggering sums into this industry despite the eye-watering upfront costs. Once built, a data center generates extraordinarily predictable, long-term recurring revenue. Cloud computing contracts with large enterprise customers routinely run 3 to 5 years, and unlike almost any other real estate asset, tenants rarely leave once their infrastructure and software are deeply integrated into a specific provider's ecosystem, because migrating petabytes of data and rebuilding entire technology stacks elsewhere is enormously expensive and risky. This is why data center real estate investment trusts have become some of the most highly valued property companies in the world, commanding valuation premiums that traditional office or retail landlords could never achieve, purely because the tenant relationships are so much stickier. Here's the counterintuitive piece. You'd think the actual computing power, renting out processing capacity, would be the primary profit driver. Increasingly, the real financial engine is the land and power access itself. Data center operators now compete fiercely to secure sites near cheap, reliable power sources, hydroelectric dams, nuclear plants, and areas with favorable tax incentives, because the availability of guaranteed power has become the single limiting factor on how fast this industry can grow, more constraining than construction capacity or even chip availability. Land near major power infrastructure that once had little commercial value has seen its worth increase dramatically simply because of its proximity to the electrical grid capacity that data centers desperately need. But this business carries genuine structural risk, and the clearest recent example is the sheer speed of technological change driving the current AI build-out. Companies are committing tens of billions of dollars to facilities specifically designed around today's most advanced chips that can become technologically obsolete within just a few years as newer, more efficient hardware generations are released. A facility built around yesterday's chip architecture can require enormously expensive retrofitting or risk becoming economically uncompetitive against newer facilities built with next-generation efficiency, creating a depreciation risk unlike almost any other category of real estate, where the building itself might last decades, but the equipment inside it can become outdated within a single presidential term. So let's do the actual math on why this remains one of the most aggressively funded sectors in the global economy. A hyperscale facility costing $2 billion to build might generate $400 to $600 million in annual recurring revenue once fully leased to enterprise and cloud customers, representing a payback period of roughly 4 to 6 years on the initial investment. A return profile that has attracted not just traditional technology companies but also private equity firms, sovereign wealth funds, and infrastructure investors who previously focused on toll roads, airports, and utilities rather than technology. The global data center industry pulled in hundreds of billions of dollars in capital investment in a recent year alone, and the AI-driven build-out shows no signs of slowing, with major technology companies announcing capital expenditure plans in the tens of billions of dollars annually just for infrastructure. The buildings keep getting bigger, the power requirements keep climbing toward levels that rival small countries, and every single facility, underneath the servers and the cooling systems and the security fencing, is really a bet on one simple premise: that the world's demand for computing power will keep growing faster than the industry's ability to build the infrastructure to support it. You didn't build a data center to rent out computers. You built a toll booth on the road that every digital service on Earth now has to travel down, and the traffic on that road has never once, in the history of the internet, gone down for very long.